Hi, so in this video I'm going to demonstrate how to do game 2 from prep test 69. Alright, so in this one we have 6 players and 9 positions. Our players will just be labeled 1, 2, 3, 4, 5, and 6, and we're placing them on shelves that are vertically related to each other. So bottom, middle, and top are the 3 shelves. The first question does it the reverse of the way that I would. So I would probably just, because it intuitively makes the most sense, have the top at the top, and then middle, and then bottom. But in the first question, we're going to have to reverse that. So it's up to you if you want to go with what intuitively makes the most sense to you or what actually is in the first question. I would prefer to go with the intuitive way because then I'm going to be able to write out the rules much more easily. It's just going to make sense to me, and then I'll just reverse it for the first question, and typically it's not going to be a problem after that. So yeah, that would be my solution. Also, if the first question does something that's different from what you want to do intuitively, you can also do what's kind of a compromise. So you can have top, middle, bottom horizontally like that, and then have the shelves vertically. So here, the reason I have 3 per is because the first rule says that we have a maximum of 3 spots per shelf. Yeah, a maximum of 3 dishes per shelf. So I usually wouldn't spend this much time working through it, but just because this is a bit of an odd game, that's going to impact what your diagram looks like. So it's okay with me personally if your diagram goes top to bottom, even though the first question doesn't match that. And it's okay if it goes bottom to top because you're looking to the first question to kind of give you a hint as to how to draw the diagram correctly. And then this is also an option as sort of a compromise that'll make it relatively easy to fill out the rules, but then also to translate that for the first question. So I'm going to go ahead and experiment with this board for this game, but if yours looks like this or like this, that's totally fine. Okay, so the first rule I've already mentioned, and that's that we have a maximum of 3 per shelf. The second rule tells us that 2 is at least 1 shelf above 6, so above is going to be left, so 2 is above 6. Okay, so at least 1 shelf above. 2 could be, the top, and 6 is the middle, but we could also have 2 as the top, 6 is the bottom, or 2 is the middle and 6 is the bottom. So those are our options. We know that 2 cannot be on the bottom shelf, and we know that 6 cannot be on the top shelf. All right, rule 3. Dish 6 is stored either 1 shelf above or 1 shelf below 5. So 5 and 6 are oriented like this, or like this. Right. So it's possible that 5 and 2 could actually be on the same shelf, right? With 6 immediately above them. That's possible. Or we could have 2, 5, 6 or 2, 6, 5. Okay. Rule 4, dish 1 is not stored on the same shelf as dish 4. So 1 and 4 are not going to be together. That's one way to write it. We could also say that, or we could say if we have 4 on a particular shelf, then we cannot have 1. If we have 1, then we cannot have 4, right? That would be our contrapositive. But if we started with, if 1, then not 4, that also works, right? We can derive the other statement from that. So a bunch of different ways to write this rule, but we all get to the same place, right? That concept is still there. 4 and 1 can't be together. Okay, so the first question is our standard acceptability question. They're going to give us 5 options, and we have to find and eliminate the ones that break the rules. So the first rule is that we have a maximum of 3 per shelf. A breaks that rule. Okay. The next is that 2 has to be above 6. So here it goes bottom to top. So we have to see 2 below 6. So we can eliminate D based on rule 2. Or sorry, no, C. My bad. So yeah, C we can eliminate because 2 is before 6. So below in this diagram. And A we eliminated based on rule 1. Okay. Then rule 3, 5 and 6 have to be, one has to be directly above the other. So which one breaks that rule? Okay, E. So with E we have 6 on the bottom and 5 on the top, so there's a buffer between them, which isn't allowed. All right, so E breaks rule 3. And 4, we're just looking for a scenario where 4 and 1 are on the same shelf, and we see that with D. So we can eliminate D based on rule 4, which means that B is the correct answer. So I would actually write B out as an example acceptable solution in the format that I've chosen. So B, we have dishes 1 and 3 on the bottom. Top, middle, bottom. We have 1 and 3 on the bottom. What do we have on the middle? Middle, we just have 6. And in the top, we have, 2, 4, and 5. So we've got 5 and 6. 1 and 4 are not together. That's good. And 2 is above 6. Okay, great. So I'll start another video for the other questions, but I do think that the setup for this one is pretty key. So once you've got the setup down, then it tends to flow a bit easier. But this one I would say has kind of like a distribution or a numbers issue because we have 6 players and 9 positions. So when we don't have a 1-to-1 ratio of players to positions, and especially when we actually don't know specifically which spots need to be filled, right? So we just have a maximum of 3 per shelf. So yeah, we don't have 6 positions laid out here, or even like minimums, right? So at first glance it kind of looks like it's possible, and I think it still is based on the rules, still possible to only use 2 of the 3 shelves. So one of the shelves could be empty. Okay, let me know if you have any questions.